Hi, everyone. My name is Mike Gualtieri. I do cover enterprise AI, and as part of that role, I get to talk to hundreds of companies who are implementing enterprise AI, as well as following all of the vendors. And as part of that, I do evaluations of AI platforms, AI infrastructure, some of which I'm going to talk about today. But I also want to take you through some of the key industry trends that we're seeing, but also the success factors, sort of the patterns that have emerged for those companies that are successful with enterprise AI. So this has continued to be a hot topic at Forrester. When I started covering it a few years ago, I was the only one covering it. And now I would say at Forrester, with all 200 or 300 of our analysts, every analyst has to cover it in some way, right? Because it's being infused into every application and every topic. So it continues to be a hot topic among our enterprises. And I think we share the view at Forrester with you that AI is the future of every enterprise. AI is software, and the future of software is software that has artificial intelligence. And since about 2015, we've been tracking this through a survey, and we ask companies, we don't define AI, but we just ask them, well, how are you adopting AI? And it started like in the low 40%. It went up a little bit. But you can see there was a very big jump between 2019 and 2020. And we estimate that by 2025, all of our large enterprises will answer yes to that question, whether they're developing it themselves or buying it in applications. And even in 2020, when we asked this question, what impact has it had on their business? 73% here, it's had a positive impact. Now, I hear a lot of things from that say, oh, people are struggling with AI and everything. I guess it's only the successful companies that talk to me, because all of the conversations I'm having, for the most part, have to do with accelerating it, going faster. And I think that's because it's gone from experimentation to business value. And that's what we've heard at this entire conference. And that's why I think we're all here. And when I do hear about the successes, they're usually, oh, we did this and it's an $80 million, or it's $100 million, or even if it's a few $1,000,000, it's still very consequential use cases. And this is often from one little itty-bitty tiny machine learning model that predicts one thing. So you can imagine how even more valuable it can get. In 2020, I did a market forecast of the spending. And we said, oh, look, there's going to be $37 billion. Now, this is a lot lower than other estimates you've seen. Here's why. Because when we first did this, we calculated, we're like, oh, well, this is $300 billion. Wait a minute, that can't be right. And it really isn't right, because one of our assumptions that we changed to come up with this 37 billion model was that, well, at what point do you stop counting any software that has AI, right? Because if you have an accounting system that has no AI and then has AI, well, you count it as AI software. But when do you stop counting it as AI? Because if all software is going to have AI, then eventually your estimate's going to be all AI software is the entire market, and the software market goes to zero. So this is why our estimate is probably lower than others. Now you can see here we've also divided this up into a few categories: platforms versus applications. So companies are going to spend both ways. From a compute standpoint, an infrastructure standpoint, this is also the fastest growing workload on the planet. Now before I move on, I'm going to start with a little quiz here, and I'd like to ask you, how well do you know this customer? Male, 35, single, New York, 125 a year. What do you predict this customer would do? Would they take the money and run, or would they give the money back? Anyone? Take the money and run? And just give me a quick reason why. You have a son that would do it. Okay. That's what they would do? All right. Yeah. I'm sure you all have some idea of an answer here. And what's fascinating about us is that we can actually answer this question, even though we don't have enough data, right? We will pull a data point to be able to answer this thing. And this is what's wonderful about each and every one of you. And this is why we will not go out of that. This is why we will not be replaced by AI, because we have that talent and AI doesn't. We have all of these cognitive biases, right? And I'm not going to go through all of them, but there's a ton of them. And they actually help us and they hurt us. So this is another reason why we love AI, is because AI doesn't have those biases. We heard that earlier today. And AI is based upon data. But there are unique challenges to implementing enterprise AI. But most enterprises can overcome them quickly. Many of you have. And maybe some of these 10 that I'm going to walk through will help you implement it even faster. Now, the first one is to prioritize high ROI use cases. No kidding, right? But a lot of companies don't do it. A lot of companies are still in that science fair, science experimentation mode, or they ask the data scientists what the use cases are, who don't really understand the business or what the high-value use cases are. And there's a ton of these use cases. We tried to count them once. I tried to do a report. Oh, here are all the use cases. And when we get up to a few hundred, we're like, we can't write a report on this. Instead, let's just put a slide and just say there's thousands of them. Because they're embedded in all of the business processes. You want to find a use case? Get a whiteboard and just walk through the business process and ask yourself a question. Is there something I can predict, decide, or is there a pattern I can recognize? There may be a use case there. We did a recent survey, actually in conjunction with C3, and you can see current enterprise applications are sorely ineffective. So I guess we could look at every single one of these applications for a potential for AI. It's all over the place, right? Predicting supply chain, cyber attacks, experiments that are more likely to succeed, right? If you're doing drug discovery, you might have to do 1,000 experiments. Which ones are more likely to succeed? Put those to the top, do those first. Machine failures, predictive maintenance, faults, all kinds of predictions and financial instrumentations, when to buy and sell Bitcoin, perhaps. Predicting lease defaults, predicting customer propensity to buy add-ons, recommendation engines. So there's literally thousands of these use cases. And when I talk to enterprises today, I'm like, hey, how many are you doing? Half dozen, dozen. So we are at the very early stages here. So that's sort of exciting. Second thing is to insist on comprehensive access to data. Now, I absolutely agree that you do not have to build a data lake first to do this. But data is a huge prerequisite to AI success, as you know. But it's not necessarily a lot of data. It's not necessarily all the data. It's the data that's likely to have the most signal in it for the use case that you're working on. And who's most likely to be able to hypothesize about what data is likely to have the signal? Is it a data scientist? No, because they don't understand the operational use case or the business use case. It's the business people. So you don't need all the data. You don't need necessarily a large data set, but you need the right data with the right signal. And that's because data is representing what's happening in the business. So for the machine to learn, it has to have a representation of physically what's happening. It has to have a representation of digitally what's happening. It has to have a representation of what customers are doing. It has to represent reality to the extent that it can. The good news is that most enterprises have extraordinarily rich data sets, and it's just waiting. It's just waiting to implement these use cases. So insisting on comprehensive access to this, what it doesn't mean you have to build a data lake. I mean, a data lake is sort of a good longer-term idea, but it's not a prerequisite to implementing successful AI. Data silos do impede that access, so you do need a connection, you do need a landing point. We also see here from this C3 survey that we did in conjunction with them, what data challenges does your company experience? Data wrangling, preparation, it's always a sort of top of the list, right? And I always say this, too, because everyone talks about the algorithms, and I always say the algorithms get all the press, but it's actually the data that leads to the success, and especially hypotheses about what data matters. Number 3, go faster with pre-trained models. Thomas Kurian talked about document AI. That's a great example of a pre-trained model. Pre-trained applications, and AutoML. Here's the analogy I use. Lumberjacks, I looked this up, I researched it. A lumberjack can fell about 15 trees a day with an axe. Do you know how many trees a lumberjack can fell with a good chainsaw? About 400 to 600. That's a remarkable increase in productivity. So what do you think a Jupyter notebook is? Do you think that's an axe or a chainsaw? Just a rhetorical question. Pre-trained models and AutoML, these are the chainsaws of data learning. Now, I know a lot of data scientists are reluctant and reticent to go to AutoML, and there's lots of different implementations of this. But if they've rejected it in the past, you should have them re-look at this. It does feature engineering, there's a lot of automation, and there's techniques that it can try that the data scientist can't use. And we estimated that data science teams can be 1,000 times more productive. So I don't understand why I do surveys and people say, oh, what's one of your biggest challenges? And they say talent shortage. Why don't you take the 6 people you have and make them 1,000 times more productive? And in some cases, an increasingly low-code type of data science tools can also make developers who understand conceptually data scientists but may not know the scikit-learn or TensorFlow, they may not know the innards of the framework, they can also be activated to develop more of these. And we asked this in the survey again, what steps is your company taking to better enable the deployment? And you can see delivering low-code training tools. And we're not saying low-code. I'm not even sure I like the term low-code. But we're not saying low-code is everything. At Forrester, we call it multimodal. So you'll have a notebook. You'll have a low-code environment. You have multiple ways to train and develop models. So definitely look into pre-trained models, pre-built solutions, and clearly AutoML capabilities. The 4th one is managing the AI lifecycle. This is another key activity because this is multiple roles. And I love the slide that we saw earlier that showed there's many different roles. It's not just the data science team. And this is one of the big changes that's occurring in the vendor market. I've been covering this market for many years. And every vendor would talk about the data science team, what the data scientist wants, what the data scientist wants. It's not about the data scientist anymore only, right? It's about this extended development team as well. And this is not even, this is an oversimplification that I've made here of the teams that get involved. But remember, what is AI? AI is software. And where does the value of software get manifested? In other software. So these two processes and teams have to intersect. And one team is outputting models, the other is outputting applications, and they have to come together. So these life cycles have to come together as well. So you have to look for tools, and if you don't have the tools, create a process that brings these together. What I look for is the ability to collaborate among these different roles, reproducing the results, versioning, change management, all the stuff that software development has gotten very mature at now needs to be injected into the data science process. Number 5 is this term MLOps, which probably all familiar with it. We don't really like that term at Forrester because MLOps stands for machine learning operations. And we think model ops is a better term because it's broader. It's not just machine learning. There's other AI technologies, and there's other intelligence technologies for that matter. My favorite is mathematical optimization. So we call it model ops. But model ops recognizes that when you trained a model, you trained it on data that represented the world, your world, operationally, or the customer's, at a point in time. And if that never changes, you're cool. But if it changes, those machine learning models must change. And this is that process, right? You train it on data, you create the model, you put it in deployment, you have to retrain it on newer data. And those models can decay in value. They can actually get to the point where you're making predictions that no longer represent the real world because the real world changed. And now you're using models that are doing great damage or harm to your company. People aren't used to that because when you write code, COBOL code, Pascal, Z80 assembler, Python, that code is going to run as written forever. May have bugs, but it's going to run as written forever. And yes, the world can change, and that's why you update software as well. But you're in control of that. With machine learning models, you probably have to retrain those models on newer data. And you might want to remodel it too, because you may want to squeeze some more accuracy out of that because you've hypothesized about some new signal or you have some new data. So models have to be retrained, and operationalizing machine learning has been a challenge. So MLOps or model ops is this repeatable, scalable process to deploy, monitor, and govern those models that are being used in production. And I'm sure that when you're looking at a platform, this is a capability that every platform has to have. Number 6, let AI help AI. So this isn't some, well, it's a bit of a trick, but I am going to say this word. It's not going to talk back, but hear me say it. This machine can recognize speech. And you know what this is. It's Alexa, right? This is an Alexa machine. This machine can recognize speech. This machine can recognize speech. You hearing this? This machine can recognize speech. You're hearing me. You're hearing me. Okay? This machine can recognize speech. 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 You get it? It was a little trick. But why are you able to see this? Because you're able to see the picture. Okay? If AI doesn't have the context, if you're only using a voice recognition and a language model, it's never going to understand that. And I can give you a lot more examples than just this. This machine can recognize speech. So this is where you really need to think not of the model, but you always have to think of plus one. Plus one. Okay, I'm doing this model for this use case, but is there another model that could complement it to make it better? So that's why I say use multiple models, because it'll boost the intelligence of the application. And maybe the first time you do the use case, it's the one model, but version 2, maybe you start adding models to give it the context. Number 7, last mile technologies. There's a lot of intersection happening now between AI and other technologies that can deliver AI, like RPA, robotic process automation, any other type of application delivery technology can be valuable in here. And I think what Tom showed yesterday morning, which is an AI platform sitting on top of your existing infrastructure. Because look, when I ask a large enterprise, they say, oh, what's your portfolio of applications? Hundreds. And if they have acquisitions, thousands. There's a portfolio of applications. All have valuable data. All are operational. People are using it. They're running the business. And what they do need is they need that intelligence layer. So AI models have to integrate with those, but consider some of the up-and-coming, at Forrester we call them IPA, Intelligent Process Automation technologies, and other technologies as well. Number 8 is keeping humans in the loop. I have to admit, I do not like the term responsible AI. It just really annoys me. I don't like ethical AI either, because why are we always picking on AI? Everything should be responsible, and everything should be ethical. Shouldn't just be AI. But anyway, having said that, we need to keep humans in the loop as well. And that's because our cognitive biases sometimes manifest themselves as intuition, as years of experience, as rules, okay? But the computers can analyze the data, okay? So we need both of these, okay? So an AI system doesn't have to just be about AI technologies like machine learning. They can be combined. So at Forrester, we believe that the best possible AI solution includes technology with human experts. Guess what, folks? Anyone around in the 80s, early 80s? Well, so was I. And in the early 80s, when I was in Kendall Square, right near MIT, every building around me was an AI company. Like Symbolics, remember Symbolics, et cetera? They were all AI companies. And it was all about expert systems. It was all about knowledge engineering and taking knowledge from doctors, air traffic controllers, and putting that in the system. That didn't work out then for various reasons. But it doesn't mean that it can't work now, especially when combined with analytical methods and machine learning models, because that's where the best decisions can come from, especially in the absence of data. But there's another point here as well, which is, why do we have to do what the model tells us to do? I talk to a lot of financial companies that say, oh, yeah, our executives, they're very reticent to use this model because, you know, it could be a loan decisioning model like I've depicted here. I want to make a $1 million loan. Here's the model says to do it. I don't know if I want it to do that. So the data scientists go back and try to explain it, use more explainability, use some more data, try to give assurances that, no, when it says, yes, make the $1 million loan, it's going to be OK. But there's a simpler answer to this problem, and that is you don't have to do it. You simply don't have to do it. You can use business rules to say, if the loan application is $1 million, don't let the model decide. Let a human decide. Do you know how many enterprise AI projects could have moved forward by simply putting a couple of guardrails like that on it? Anyway, this is one of the observations I've had with enterprises that have been successful with this. Number 9. AI infrastructure wasn't very important a few years ago for enterprises, because enterprises were mostly working on smaller data sets. They weren't necessarily using deep learning. A few were, right? A lot of the internet giants were all using deep learning. But now, deep learning, multiple techniques, more use cases, even AutoML. The reason why AutoML makes your teams 1,000 times more productive, because it uses brute force of compute to try lots of combinations rather than using a human. So AI infrastructure is very important as well. It's important for the resiliency of these systems, but it's also important for the scale that's needed as well. Q4 last year, a few months ago, I did a wave on what we called AI infrastructure. It's the hardware people, okay? And we put them all together, cloud and more hardware you can ship to your data center as well. And you can sort of see the results here. But what I have to say about this is cloud is a great option. But the reason we did this wave is because a lot of enterprises would call me and they'd say, cloud is so expensive. It gets expensive if you're running hot. If you're retraining and running models around the clock, and if you're AT&T and you have a big old data center with some square footage, you might be able to save $1 million a month by buying, one of these vendors as well. So it's not automatic cloud. Cloud is great for, cloud is a great place to start, but look at NVIDIA's DGX business. Whoa, that's a multi-billion-dollar business right there of hardware. So it's going to be a mix. It's going to be hybrid. Yeah, so the infrastructure is also critical too, because you have data scientists like the old days, like what Tom mentioned. He put his cards, didn't he put his cards in a computer, and then he went away, had a coffee, and then he came back to get the printout? You don't want that happening with your data scientists. So you have to invest in this hardware as well. And number 10, use an AI platform. I've seen, and our surveys have shown that companies that use an AI platform are able to implement more use cases faster and support larger teams as well. And there's a lot of vendors out there that have the focus on the data, right? Everyone loves to say, oh, it's all about data. It's about data and insights. It's about insights. So they'll sell you on the data platform notion, because that's where the strength is. Some of the ML platforms will focus on the models, the data scientists, because their strengths are with the data scientists. Well, the platform focuses on the intersection of all of these things with a huge emphasis on the business value that gets manifested through software applications. We did not always cover it this way. We did not cover it as AI platforms until very recently. We used to call it predictive analytics and machine learning. And you know what we called it 8 years ago? Data mining. So what's happened is this category has evolved, and hundreds of millions of dollars have gone into startups, new ventures, to create AI ML platforms. And that's kind of where the industry is evolving. Okay, so if I think back to my time as a developer when I was using Turbo Pascal, did anyone use Turbo Pascal? Cool, awesome. I would still be using that right now to develop a B-tree system. But software development tools have gotten more sophisticated. They've gone into platforms, to applications. That's what's happening today in this market, and that's why we call it the AI ML platform market. I'm not too thrilled about this AI ML platform term, because AI is sort of the application, ML is the technology, but this is what the market refers to it. I'd rather just call it an AI platform. And these platforms are designed for the full life cycle and for all of those teams to build applications. It's not for data scientists to build models. It's for AI teams to build applications. So those are a quick 10 observations that I've made from the research. Super happy to be here with all of you, because we're all in this AI world together. But I would like to end with a quiz, though. How well do you know this customer? Male, 35, single, New York, 125 a year, take the money and run, or give the money back. Don't answer, because you've already answered. You've already thought about this. And I've already told you that you didn't have enough information, and you know that. But now I'm going to give you some more information. And when I give you more information, I'd like you to tell me what this individual will do. You ready? You are? Okay. What's he going to do? He's going to take the money and run. What's your probability? 100%. Thank you.